we are going to begin our PowerPoint exercise. The first thing we want to do is make sure that it is reset to default by following the instructions in the printout, resetting to factory drive default, which involves setting parameter PO41 to 1, which will cause it to, if we hit, make sure the drive stop, select. We already see PO41 is selected. We'll select that, we'll enter it, we'll set this to 1, and then you'll get a fault, which is normal. We've reset or cleared the memory, so we have a new exercise from the last group. So we're going to hit stop. So now we're at default. So the first thing we want to do is you can look over your worksheet. You have skill 2, it's in there. Program and connect a variable frequency drive for 3-wire control. We're going to modify it just a little bit. Notice that the minimum frequency is set for 20 hertz. This motor is probably inverter rated in this little kit, but typically speaking, a normal induction motor should never run below 20 hertz. Because if it has a fan blade below 20 hertz, it doesn't move enough air across it to cool the motor adequately, and it can overheat. You can run it below 20 hertz for a brief period of time. This motor in this kit could probably run all day, but just for grins and giggles, we're going to modify that and say 20 hertz is as slow as I want to run an induction hertz motor. And you can go standard induction motor. If you use a Baldor motor, you can double speed them. So if it's rated for 60 hertz, you can easily go 120 hertz, because all Baldor motors have a high-speed bearing installed. So. But just be aware, inverter duty rated motors have different types of bearings and cooling systems for the most part. So running to those extreme frequencies can cause the motor to become damaged. So we're going to set our parameters for this sheet, and then we're going to watch it work, and we're going to enable it. First thing I want to do is make sure that my signals are working. I'm going to do that by opening, I have the manual here for this drive. I want to go to my display parameter group and want to make sure that all of my drive inputs are functioning. One thing you also need to make sure on these drives, especially when you're hooking them up new, if we look right here between zero and 1, I've removed it, but they come pre-installed with a small yellow jumper. This is the stop bit enabled. This one I've just taped off because this isn't our trainer and it has to go back. And so at the end of this, whoever's done with this trainer, whatever teacher needs to hook that back up to 1. So that, if we look on the back of the drive parameter sheet, we'll see that the 1 is the stop bit and 11 is a 24-volt source. So 11 to 1 has to be jumpered. If you're using a stop button, which we'll be using, you'll have to remove it. You'll see that it is already wired up. So our stop button is going to take the place of that jumper for 3-wire control. So we're going to just leave this one disconnected for now. Next, we're going to monitor our I/O that we have hooked up to this drive. If you have a Powerflex drive and it's connected to a ControlLogix over Ethernet, you can actually use that data that comes into that device on these extra digital inputs and verify that you can use them as a remote I/O for remote stop button, etc., and pull those into a PLC program. First thing we want to do is go to hit select. We are going to go to the D parameter group. We're going to hit select again. There's some parameters we want to look at under the D group, which does nothing for setting the system up. We simply want to make sure that our signals are getting to the drive. So we can start with our D14, which is our digital in status. So we're going to set that to 14, and it's going to display in a binary format. You'll need the manual and understand what these bits are. But if we see here digital 1 in, when I turn the digital 1 selector switch here, we'll see that we get a 1 here. And when I turn this one in, we'll see that we get another one. Bit 2 and 3 are not used in this example. So now we'll go on to the next digital display. This is also a good troubleshooting tool to make sure your signals are getting to the drive. We're going to go to D20, which is going to test our analog input, 0 to 10 volts. We don't have a 4 to 20 hooked up on this. So we're going to go to D20, and we'll adjust your knob and make sure that it does go to 100%. So 0 being 0 volts, 100% being 10 volts. So we see that that works. We're going to skip DO21 analog, but if you do have that, you need to check that. What these knobs are is for typically speed control. We may have missed one of our we should have went DL13 first, but that's okay. Let's go back to DL13. That's going to show us the status of our bit. So first I'm going to hit the stop button. We'll see that the stop bit is actuated. Now I'm going to hit the forward switch. We'll see that that actuates. And I'll hit the reverse switch and make sure that works. So now we're ready to set this drive up for 3-wire control. All our signals are wired appropriately and in the drive. So now we're going to install this cover back on here. Remember that below here is the high voltage. So above here, no high voltage. So you need to be extremely careful and have your teacher monitor what you're doing here. Next, we'll set up some basic parameters, and we will set those up just like this worksheet with a modification of 20 Hertz. Nameplate voltage, we can't see the nameplate on this motor, but I do know it's 220. We'll just go by default on that. It's more than likely lower than 1.6 amp, but we're just going to leave that alone on the worksheet. This has internal fusing as well, so it'll be safe. So we're going to go to our motor nameplate, which is, if we go here, we're going to select, we're going to hit select again, and we're going to go start at PO31. We'll hit enter, which is the right arrow or left arrow, so it is set for 230 volts. We will continue to go through here. Let's see if we can't get all of our settings up here where you can see everything. Most of it. So I'm going to go through here and adjust these settings as needed. Next we'll do 60 Hertz, which will be the next one. We'll hit the up arrow. We'll see that set for 60. Next we'll go to P33. We'll see that that is set for 1.5. Our manual says to set it to 1.6, so we're going to hit the up arrow or select to go into that sub menu. We'll hit enter. We hit escape to back out. Next we're going to set our minimum frequency. We're going to set that for 20 Hertz. Remember what I said about that. So we're going to turn that. If you get tired of that, you can hit select and go to the next digit. So we're going to come up here to 20 Hertz. Hit select again. See how I can go to all the digits. And I'll just roll that over. We'll hit enter. Next we'll go to PO35, which is maximum Hertz, which is set for 60 already, so we don't have to modify that one. Now we're on PO36. We're going to hit enter. Now this is set to start from this HM on the front. We want to change this to external control. So we want to change our start source to 3-wire control, just like a stop-start circuit. So we hit 1. Now we're at 3-wire control. And 37 we want to modify. No, it's set to ramp, which means when I turn it off, it'll simply coast down. Our frequency setting is set for internal frequency. We don't want that because we have the knob. So if we look right here under our indications, it says options include 0 for drive pot, 1 for internal frequency, 0 to 10 volts, is going to be 2 or 3. That instruction is a little confusing, but if you refer to the manual under that status, PO36, it says PO38. Says 2, selection of 2 is going to be our 0 to 10 volt signal. So we're going to go in here and set that to 2. Alright, and then we're going to hit escape. Then we're going to come up to our min and max acceleration rate. I'm going to go ahead and I'm going to modify these. I want to turn them down to 1 second. 5 is a little bit long. That's how fast it takes to speed up and go down. So we want to change those to 1 second. So I'm going to come over here and put those down on 1 second, both of them. Put P40. We'll hit select to enter. Set that to 1 second, and we'll hit enter. And we'll escape out of that, and now we should be able to see our drive run. We will come a little, we're going to kind of turn over here where you can see the other one. So we're going to enable our start bit. We'll see this runs. We'll see our frequency. We go down here to the bottom, it's 20 hertz, that's the minimal. And if I turn it up here, it should run to 60 hertz. When I hit the stop button, the drive should coast to stop. And it ramps down in about 1 second. Next, we're going to modify this. What we're going to do now is modify this to add our DC braking. This DC braking is an option on most of your drives. And what that's going to do for us is it's going to take one coil of the motor, one set of coils, and it's going to inject a DC. So it's going to magnetize one pole all the time. So as it comes around, it begins to slow the motor down. One of the things you have to worry about is regen on the drive. These have external brakes because a motor that is not being driven is a generator. If you drive a motor, it becomes a generator. And so if you don't have a heavy torque load, you will not be able to use this feature without the external braking. And we're going to set it to the extreme. So for practical purposes, you'll never set a DC brake this high. But we want to see this motor instantly stop and hear the high-pitched frequency hum of the DC injection. So we're going to come over here and we're going to modify PO37 stop mode to 6, which enables our DC injection braking without any overload. So this is just going to hammer it. Next, we'll have to do some advanced parameters. So we're going to go up to the A group, and we are going to select the A80 function, and we are going to set that to enable braking for 1 second. So we'll hear a high-pitched hum. You can turn this up. This is bad on a motor if you turn this way up, but for our purposes, 1 second should work. Next, we're going to go to 81, and we're going to up the level. So if you look in your manual, there's a little equation for what this term means, but for our purposes, we're going to run it up to 1.5, which should give us a nice braking function with no load. Hit escape. Now we're going to start the motor. To re-enable that input, we'll run it up here to about 60 hertz, let it get up to speed. Now we're going to, and when you do this, you'll hear a high-pitched hum for about 1 second. And you hear that hum as it magnetizes the brake, one side of the coil, and immediately stop that motor. Like I said, these don't have any torque. You couldn't pull this off on a little Powerflex unless you had dynamic braking enabled and a dynamic brake resistor hooked up. So let's see that one more time. We're going to run it at high speed, and we're going to hit it with DC injection braking. And there we go. Maybe we want to run this the other way. So in our 3-wire start-stop, if I change this direction switch, I can go the opposite way by hitting this. Notice that the reverse indicator on the drive comes on, depending on what direction I want to run. If I look over here on the drive, I can use the direction control. Here's my direction control. See the little indicator light that tells me what it's doing, and we'll run it. We'll hit it.